Let's say there are two investment opportunities, A and B. A pays you $1,000 at the end of each year for 20 years. B pays you $1,000 at the beginning of each year for 20 years. The discount rate is 10%. Which one of these two investment opportunities is more valuable in today's dollars, and by how much? So we need to compare today's values of these two investment opportunities. In other words, think of it as comparing an equivalent of receiving $1,000 20 times, but an equivalent of that would be receiving one large amount of money today, right? So how much would that one large amount of money today be equal to for case A and case B? And then compare those. So in other words, compare the two present values. So we have an annuity going on in this problem, right? $1,000 is repeated again and again and again at the end of each year. So it's an annual repeating payment. And we have it 20 times. Same in case B. How do we find the present value of the first annuity in case A, where the payments are at the end of each year? We already know the formula from before, where we use 1,000 for the payment, 10% or 0.1 in decimals for the interest rate throughout the formula, and 20 for T, the number of payments. That gives us $8,513.56. Of course, we can use the financial calculator. Let's move it here. First, clear everything. 1,000 is our payment, so 1,000 negative PMT. We have 20 of those, 20 N, and the interest rate every year is 10%, 10 IY. Compute present value, $8,513.56. Okay, now what about case B? In the second case, if you compare it to case A, the only difference is that since everything is at the beginning of each year, everything starts sooner. Everything is 1 year sooner. The first $1,000 in this investment opportunity will be received by you today. You wouldn't need to wait for it for 1 year, right? The second $1,000 will be received in 1 year, whereas in case A, you would need to wait for 2 years for that, right? Everything is sooner in case B. Do you value this investment opportunity in case B higher or lower? I would definitely value it higher because it's sooner. I get all my money sooner, right? I don't need to wait for it. Waiting kind of costs money, essentially. And the way we should look at how that will affect our numerical answer is we don't need to discount those $1,000 cash flows so much, right? We want to undo 1 year worth of discounting for every single one of them, right? They're not going to be discounted by 1, 2, 3, all the way to 20 years. They're going to be discounted by 0, 1, 2, all the way to 19 years. There's 1 year less of discounting for each of these 20 $1,000 cash flows. And mathematically, to undo the discounting, we can multiply the answer we had in case A by 1 plus the interest rate. So it's like we are taking $8,513.56 and bringing it into the future by 1 year, right? Because really, if you compare the timelines, case B is like, it's as if we just move the question mark in case A from, into the future by 1 year, right? This is where we want to be, where the first cash flow occurs. And so it's like we want to be in the future by 1 year. And that's this, adjustment we are doing to our calculations. So the fastest way to get the answer would be taking the answer from case A and multiplying by 1 plus the 10% interest. And we get a larger number, $9,364.92. Intuitively, the larger number in case B reflects the fact that we like this investment opportunity better. We get our money sooner by 1 year. Who wouldn't like that? And in the financial calculator, this step we just did could be done by, let's clear it all first, by finding the future, the future value of a single cash flow. So I guess in the formula I put here, it kind of looks like we are finding the present value, which is correct, but we are, finding it as the future value of, the present value we had in case A after 1 year. So it might look a little bit confusing here. Okay, so the present value of the 20 identical future cash flows in today's dollars can be found by taking the answer from part A, which is 8,513.56. Make it negative, that's your PV. And we want to bring it into the future by 1 year. So this way we are sort of adding back 1 year of discounting. We are undoing it. We are undoing 1 year worth of discounting. So I press 1N. The interest rate is 10%. I press 10 IY, and I'm computing future value, $9,364.92. And then you can compare the two results in cases A and B, and the difference between the two present values that we found is $851. So the opportunity to receive the money sooner by 1 year is more valuable by $851. Now, just like with annuity future values, annuity present values also have, two formulas. One for an ordinary annuity and one for an annuity due. Same interpretation as before. An ordinary annuity is sort of the default case when the cash flows are all at the end of each time period. For example, at the end of each year. An annuity due is when the cash flows are due immediately. So they are all at the beginning of each time period. And the transition from an ordinary annuity present value to an annuity due present value is done by this multiplication by 1 plus the interest rate. And so the present value of an annuity due is always bigger than the present value of an ordinary annuity. And something important, this was exactly the same for the future value of an annuity due versus the future value of an ordinary annuity. With future values, it's the same, result. An annuity due future value is also always bigger than an ordinary annuity future value. So it's true for both present value and future value. And again, there is a way to tell the calculator that the calculations I'm about to do are going to be for an annuity due case. So you can set your calculator to the annuity due mode or the so-called begin mode. If you go back to this slide, to cases A and B, then here's what we can do. So let's, reset the calculator first. Everything is cleared. Then I want to tell the calculator that I'm setting you in to the begin mode or annuity due mode. Press 4 buttons. Second, payment. Second, enter. If you turn it off and back on, you will see the small letters BGN, begin. The calculator is now in the begin mode. And then try to follow the steps that we did in part A for an ordinary annuity and see what you get. We did $1,000 for our payment amount. We made it negative. We pressed the PMT button. Then, because we have 20 of those, we pressed 20N. The interest rate was 10% per year, so we pressed 10 IY. And with this information, we wanted to compute the present value. But look at what the display gives you. It doesn't give you the answer for case A. It gives you the answer to case B, right? 9,364.92. And that's because you told the calculator before you put in all these numbers that were given that we are going to be now in the begin mode. So you can switch between the end mode and begin mode very easily by pressing second, payment, second, enter, right? Which is also explained on the bottom of slide 42. So you set the calculator to the begin mode, and then you do the calculations like for an ordinary annuity. But that gives you the answer for an annuity due. If you want to go back, then you can either press second, payment, second, enter again, and that will take you back to the ordinary annuity case. Or I just simply reset my calculator. It works even faster. Let me show you the cash flow keys using the most recent problem with cases A and B. So let's look at case B, an annuity due. Clear everything, right? Actually, let's start with case A. What's going on in case A? How can you do it using cash flow keys? Cash flow 0 is nothing, so you leave it as is, press enter, down arrow key. Then we have $1,000, right? 1,000, enter, down. What's the frequency of it? It's not 1, which is the default, it's 20. You put 20, enter, down. There is no more cash flow that needs to be entered. You're done with all 20 of them. Then you press NPV. It asks you for the I, the interest rate. You put 10, we have a 10% rate. 10, enter, down, compute. $8,513.56. Now, what will be different for case B, an annuity due with the $1,000 payments occurring at the beginning of each year? Make sure you clear the calculator, it's important. Cash flow key. What's cash flow 0? It's no longer $0. Now the first $1,000 occurs immediately, and that's what you need to put in the calculator. 1,000. Enter. Down. What's cash flow 01? The first one in the future. It's $1,000 in 1 year. You put 1,000 again. Enter. Down. What's the frequency of it? How many times in a row will we have it? The right number is 19, because the 20th, we already took care of that with cash flow 0, right? There are 19 more left in the future, 1 through 19. So this is the right frequency. Enter, down, no more, you press NPV, the discount rate is 10%, 10, enter, down, compute. $9,364.92. So maybe this is a little bit tricky in finance, that oftentimes there is no single way to solve a problem. Or maybe it's a good thing, because some of you prefer one method, others find a different method more intuitive. So this way there will be the right method for each one of you.